In algebra, the difference quotient is the rate of change of a function relative to the horizontal or x-axis. We saw a rate of change before in algebra, and that was when you found the slope of a line. But now we're working with functions that may or may not be straight lines. So we can have a curve and still talk about how that curve is changing with respect to the x-axis. And the formula for doing this is f of x plus h minus f of x, and that's all over h. And the reason for this particular formula, I'm going to take out the denominator for a second, is because this is really the slope formula. So we have the y value at a certain value, x plus h, and then the y value at just x without the h. And we're subtracting those. So it's the difference between two y values, which is the numerator of the slope formula. And then in the denominator, we want to subtract the x values, and that's x plus h minus x. But as you see, that's just going to simplify to h. So that's where our formula comes from. Now let's take a look at a particular problem and see how to find the difference quotient. In this example, I need to find the difference quotient for f of x equals 5x minus 3. Now this function is the graph of a straight line. So when I look at the slope, which is 5, that should be my answer when I compute the difference quotient. But we're going to work through it and see if that is what we get as an answer. So I started by writing my formula, and then I plugged in x plus h where I need to. So we have 5 times the quantity x plus h minus 3, and that's f of x plus h, and then minus, we have that here, and remember to use parentheses here, and f of x is just 5x minus 3, so that's what I put inside the parentheses, and that's all over h. Now I'm going to go through and simplify this just using the distributive property and combining like terms. So when I distributed, I got 5x plus 5h minus 3 minus 5x plus 3, and that's all over h. Now I can combine like terms, 5x minus 5x, well those cancel out, and you'll see that a lot with the difference quotient. There's a lot of terms that'll cancel out, and then minus 3 and a plus 3 cancel out. So that leaves me with just 5h in the numerator and h in the denominator. So at this point I can simplify by dividing both by h, and I get 5 as my answer, which is what I predicted because that's the slope of the line. So that's the answer for this problem. Now in this problem, we need to find the difference quotient for f of x equals x squared plus 4x minus 7. So again, I've written my formula, and then I plugged in x minus h, should be x plus h, right? X plus h for x in the function f of x. So it's x plus h quantity squared plus 4 times x plus h minus 7, and then that's all minus x squared plus 4x minus 7. And that's all over h. So now I'm going to square the x plus h squared, and then I can combine together my like terms, use the distributive property, all of that. Now I've simplified, and I have 2xh plus h squared plus 4h, and that's all over h. So in my last step, I'm just going to divide each of the numerator terms by h. They all have an h in it. I could factor out the h. I'm just going to go ahead and divide, and I get 2x plus h plus 4. And that is my final answer. In this example, we need to find the difference quotient for f of x equals 8 over x squared. So I'll start this the same way I do the rest of them by writing out the formula and then plugging in x plus h in place of x where I need to. Now, I've got f of x plus h minus f of x all over h equals 8 over the quantity x plus h squared minus 8 over the quantity x squared, and that's all over h. So at this point, I want to simplify the numerator, and since I have two fractions in the numerator, I'm going to find the least common denominator and then combine those two together. Now I have 8x squared over x squared times x plus h squared minus 8 times x plus h quantity squared all over that same denominator, and then that's all over h. So I will now use FOIL and the distributive property and then combining like terms to combine the numerators of these two fractions together because they have the same denominator now. And now I have 8x squared minus 8x squared minus 16xh minus 8h squared, and that's all over that common denominator of x squared times x plus h quantity squared all over h. And so I can do my last little combining of like terms, and I get negative 16xh minus 8h squared all over x squared times x plus h squared, and then that's all over h. So at this point, I really don't want to have a fraction within a fraction, so I'm going to take care of that right now. And so how I'm going to do that is I'm going to turn this into a division problem. So I have the numerator divided by h, which is the denominator. And of course we know when we're working with fractions that we never really do division with fractions. We always turn it into multiplication and multiply by the reciprocal. So I'm just multiplying by 1 over h. And so now all I have to do is put the h with the denominator, and that gives me negative 16xh minus 8h squared. You probably can see where this is going. X squared times h, I'll just put it in the middle there, times x plus h quantity squared. And now I'm going to divide each of the numerator terms by h. And I have negative 16x minus 8h all over x squared times x plus h quantity squared. I really could have done that division in the last step, and I didn't need to do that. That's all right. So this is my final answer, and that's the end of that problem.